I don't remember too.
SN2 reaction. SN2 reaction. It just an normal SN2 reaction. What is the starting material? You don't remember the SN2 reaction?
Yes.
Okay. See me again next year. Okay, thank you. Lê Hoàng Long. Lê Hoàng Long. Are you there, Long? Lê Hoàng Long. Lê Hoàng Long. Lê Hoàng Long. Are you there, Long? Lê Hoàng Long. Lê Hoàng Long. No. Nguyễn Cao Bảo Long. Nguyễn Cao Bảo Long.
Yes.
Okay, tell your friend how to make this nitrile. Just carry one single SN2 reaction.
I think we can get it from
read CH3.
After highlight.
Okay, read the name. Read the formula. Say the formula. CH3.
CH3, CH2, 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 Br.
Oh, Br
and cyanide.
Okay, good. Okay, cyanide. It's just an SN2 reaction. Okay, from cyanide, and then we have this one. Okay. Let me ask your friend one more question. Thank you. Nguyễn Thị Minh Ngọc. Nguyễn Thị Minh Ngọc. Are you there, Ngọc? Nguyễn Thị Minh Ngọc. Are you there, Ngọc? Ngọc. Nguyễn Thị Minh 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 Ngọc. Absent. Châu Hồng Nhung. 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 Absent. Nguyễn Phúc Thành. Nguyễn Phúc Thành.
Yes.
Okay, thank you. Can you tell your friend the reaction between this cyanide, C triple bond, and with water and acid catalyst? What is the product? I mean the hydrolysis reaction. What is the product?
With the triple bond CN.
C triple bond N with water and acid catalyst. And then what is the product?
I think it will make a double bond O.
What else? Only double bond O?
One.
Only
one double bond O product.
C double bond O, and what else? Is it a ketone? Ketone, aldehyde, or carboxylic acid? Ketone, aldehyde, or carboxylic acid?
I think it is carboxylic acid.
Okay, thank you. Okay, thank you. Good. Okay, so if we carry out the hydrolysis of this one, we have carboxylic acid. Okay, thank you. Okay, we can have amine from the reaction of amide. Amide, you can say amide or amide. Okay, amide. Okay, CO, double bond O, and N. We carry out the reaction, and I told you already. You cannot use sodium borohydride. I mean NaBH4. Do not use that one. The only reducing agent we can use is lithium aluminum hydride. Okay. So if you reduce this one, we have amine. Okay, here we have a very interesting reaction, very popular reaction. Okay, aromatic amine. Okay, we can have aromatic amine. Aniline derivative. Okay, derivative. Okay, you can say derivative or derivative, both. Okay, we can have aniline from nitro compounds, from nitrous. Okay, we can reduce nitro. And then we have aniline. Okay. We can use hydrogen. with liquid with catalyst, or we can use hydrogen, activate hydrogen. I mean the hydrogen atom. Okay, by using iron and hydrochloric acid. Okay, and we reduce NO2 to NH2. Okay, you will see this reaction million times in your exam. Okay, so be careful with this one. Okay, there are two ways we can use hydrogen, molecular hydrogen with a transition metal catalyst like nickel, palladium, or we can use a mixture a metal. Normally iron is cheap. Okay, iron and hydrochloric acid. Okay, iron reacts with hydrochloric acid to form hydrogen, and hydrogen reduce nitro to amine. Okay, this is safer, because the hydrogen tank is more difficult to handle the hydrogen tank. Okay, hydrogen can form an explosive mixture with oxygen. Okay, so in the industry, people use the mixture of iron and hydrochloric acid instead of molecular hydrogen. Okay, if there are two nitro groups in the molecule, okay, and we want to reduce one group and keep one nitro group in the molecule, we need to use a very soft, very weak reducing agent at 1:1 molar ratio. Okay, and normally people use sulfite. Okay, sulfite. Okay, you can use NH4 2 times sulfur S, or you can use Na2 sulfite. Okay, with sulfite. Okay, this is a weak reducing agent. As the reaction occurs slowly, so we can get one nitro and one NH2, one NO2 and one NH2 in the product. Of course, if we use excess reducing agent, both nitro groups will be reduced to NH2. Okay. We can have amine by reductive elimination. In chapter 11, we studied the reaction between C double O and amine. Okay, so we have imine, C double bond N. Okay, and after that, we carry out the hydrogenation reaction. Okay, then the hydrogen we add to this double bond, and then we have amine. Okay. We can also use a reducing agent. Okay, we can also use a reducing agent to reduce this C double bond N. Okay, the boron can do the job. Okay, however, this is a little bit expensive, so normally people don't use this method. I mean, there are many better ways to make amine. Okay. So first we make C double bond N from the reaction between C double bond O and an amine, ammonium amine. Okay, and then we reduce the C double bond N. Okay, to C single bond N. Okay, by using hydrogen, a molecular hydrogen with transition metal catalyst, or we can use a reducing agent with boron. Okay. We can carry out make amine by Hoffman rearrangement. We lose one carbon, but ignore this slide. You will not see this reaction in your exam. Okay, we can use bromine and sodium hydroxide. Okay, and we lose one carbon. Anyway, you will not see this reaction in your exam. Okay. Okay, that's how we make amine. Okay, in amine we have nitrogen, and on nitrogen we have 2 electrons. Okay, if we have more electrons on the nitrogen, the amine is more basic. Okay, if we have less electron on the nitrogen, the amine is like basic. Okay, so the amine connected with electron donating, okay, is stronger than amine in which the nitrogen is connected with electron withdrawing. Okay, so electron donating make the base stronger, and electron withdrawing group make the base weaker. Okay. Okay, so what is the reaction of amine? I told you already in chapter 11. Okay, first the reaction between C double bond O and amine, primary amine. We have C double bond N, imine. Okay. The mechanism is the same with any nucleophilic addition. You know, look at the C double bond O. The oxygen is electron withdrawing. The carbon is a little positive. The nitrogen is a little bit negative. So negative add to positive. Now after that, we remove one water molecule, and then we have imine. For secondary amine, because there is only one hydrogen here, so in the elimination reaction, I mean dehydration reaction, we make C double bond C and single bond N. Enamine for secondary. Okay. Amine can react with carboxylic acid derivative. I told you already. It's very easy to remember. Just remember the esterification reaction. Okay. If here we have CH3OH, then the product is C double bond O and O. That is ester. Okay. Remember the ester, and then replace the oxygen in the alcohol by the nitrogen. I mean, replace the alcohol by amine. Then we have amide. Okay. If I say again, if this is oxygen, I mean, if this is alcohol, then we have COO. That is ester. Okay. And if we have amine here, then we have CON, amide. Okay. We can also have the something similar to the transesterification reaction. Okay. Look, if we have CH3OH here, okay, then we have COOCH3. Okay. That is a transesterification reaction we study in chapter 12. Okay. And then we replace the oxygen by nitrogen, and then we have amide. Okay. Same with anhydride. Okay. If we have CH3OH here, what is the esterification reaction between alcohol and anhydride? And then we have COO. If we replace the oxygen by the nitrogen, I mean, if we replace the CH3OH by CH3NH2, then we have CONHCH3. Okay. So I told you already in chapter 12. Okay. Just remember the esterification reaction. Okay. And then just replace oxygen in the alcohol by the nitrogen. I mean, replace the oxygen. Replace the alcohol by the amine. Okay. Then we have amide instead of ester. Okay, easy to remember. Reaction alkyl halide. I told you already. It is just SN2 reaction. You know. Look at the CH2. I mean the alkyl halide. The halogen is electron withdrawing, so the carbon is positive, the nitrogen is negative. So we have just SN2 reaction. Okay. From ammonia, we have primary amine, then we have secondary amine and tertiary amine, and then the ammonium salt. Okay. Ignore this reaction. Okay. Ignore this. There's nothing wrong with this reaction, but we don't use something expensive to make something cheap. Okay. You will not see this reaction in your exam. Ignore this reaction as well. You will not see this reaction in your exam. Okay. you will not see this reaction in your exam as well, but I want to tell you something. You know, when we reduce nitro, we have amine. Okay, if you reduce NO2, then we have NH2. And if you oxidize NH2, so the final product is NO2. However, you will have a mixture of many intermediate products. We have NHOH, NO, and then O2. Okay, so this oxidation reaction will give you many products, and we don't like that. Okay, so do not use this reaction in your exam. All right, now we move to a very important reaction. That is reaction with nitrous acid, HNO2. Okay, HNO2. Normally HNO2 is not stable. Okay, it's very easy to get decomposed. So instead of using HNO2, people use sodium nitrite. Okay, the acid is nitrous acid. Okay, the salt is nitrite, sodium nitrite. I mean NaNO2 and hydrochloric acid. You know, HCl react with NaNO2 to form HNO2. Okay. So look at the structure of HNO2. Okay, you know this oxygen is negative. Okay. The proton is positive, so negative combined with positive, we have HOH, and we remove one water molecule. So what is left? It is a cation, nitrosonium ion, a cation. Okay, so we remove water, and we have something positive here. Look at the structure of aniline. You know, look at the nitrogen. You know, on this nitrogen, we have 2 electrons. So this nitrogen is a little bit negative, and this NO is positive. So positive will attack to the negative. Okay. Okay. So we have this one. All right. And eventually, we remove one water molecule. Remove one water molecule. Okay, you remove one water molecule, and then we have N triple bond N and triple bond N. That is diazonium salt. Okay, this is the cation. Of course, we have something negative, the counter ion. Okay. For secondary amine, you know, for primary amine, we have 2 hydrogen here. Okay, so we can remove one water molecule. But for secondary amine, we have only 1 hydrogen here. So we cannot remove any water molecule. So the product is nitrosamine. For tertiary amine, we have no hydrogen. Okay. This nitro will attack to the ring. Okay. In your exam, you just see the reaction between primary amine. Okay. Primary amine and nitrous acid. Okay. In your exam, you will not see the reaction between secondary amine or tertiary amine with nitrous acid. Okay. But I want to tell you something about nitrosamine. You know, long time ago, I mean 30 years, more than 20 years ago, okay, 30 years ago, the number of people who got stomach cancer, you know, stomach cancer in Western countries, I mean in Europe, in America, Canada, okay, the number of people who got stomach cancer in Europe, in Western countries, were double the number of people who got stomach cancer in Asia long time ago. But nowadays, the two numbers are almost the same, approximately the same. Okay, why is that? You know, people in Western countries eat a lot of food such as ham, sausage. You know ham, sausage. Okay, in ham and sausage, people use sodium nitrite and NaNO2 to reserve the food. Okay, and when you eat that, okay, in our stomach we have acid. Okay, so the acid in our stomach will react with NaNO2, and then we have HNO2 in our stomach, and of course in the food we have secondary amine. Okay, so we have this reaction. Okay, and then we have nitrosamine, and nitrosamine can cause cancer. Okay, nitrosamine is very toxic and can cause cancer. Okay, long time ago, you know, people in Asian countries, you know, for example, in Vietnam, okay, in our country, long time ago, we had fish, a lot of fish, a lot of vegetables. Okay, and 30 years ago, we did not eat sausage or ham a lot. Okay, but nowadays we have everything in our city, in Ho Chi Minh City, in Vietnam. Okay, we have lots of sausage, we have lots of ham, lots of Western food. Okay, the same for other Asian countries. So nowadays, the number of people who got stomach cancer in Eastern countries almost the same with the number who got stomach cancer in Western countries. Okay. Okay, so we have diazonium salts. Okay, we have diazonium salts. Okay, so what can we do with diazonium salt? Diazonium salt. Oh, I forgot to tell you something. It's not for your exam, but I want to tell you something. You know, at home normally you use microwave oven to cook your food, to warm up your food, or to heat your food. Okay, remember, do not put sausage or ham, both Western sausage and the Chinese sausage or the Vietnamese sausage. Never put this food in the microwave oven. You know, the microwave oven will accelerate the reaction. Okay, between the nitrite and the amine in the food. Okay, and it might produce some chemical that might cause cancer. Okay, so do not put sausage, do not put ham in microwave oven. Okay, if you need to warm it up, just use the traditional method. Okay. What is the reaction of diazonium salt? Okay, first is the Steinmeier reaction. Okay, that is the reaction between diazonium salt and copper-1 bromide or copper-1 chloride. Okay, so we make Br bromobenzene here. Okay, but do we need to use this reaction if you want to make bromobenzene? Let me ask you something. Trần Thanh Tuyền, are you there, Tuyền? Trần Thanh Tuyền, I'm not sure. Absent. Lý Quang Vinh, are you there, Vinh? Lý Quang Vinh, you absent. Let me ask you something. Lê Phạm Hoàng.
Yes.
Okay. If you want to make bromobenzene, I mean this one, what is the best way? Hoàng,
I think we use benzene plus with Br2 with the catalyst Fa. Yes.
Fa.
Fe. Yes.
Okay, thank you. Okay, thank you, Hoàng. If you want to make bromobenzene, just carry out the normal bromination reaction, the normal electrophilic substitution reaction to the benzene ring. Okay, so if you want to make bromobenzene, you don't need this one. But sometimes we need to use this reaction. Let me stop sharing it and show the chemistry for you. Okay. Chapter 12. Let me share. Let me open the file. Okay. Okay. So if you want to make toluene, okay. If you want to make this one, para-bromotoluene. If you want to make this one, okay, then just carry out the bromination reaction. Just a normal bromination reaction. Okay. Okay. We don't need diazonium salt. But if you want to make this one, if you want to make meta-bromotoluene, okay, if you want to make this one, okay, you cannot carry out the direct bromination reaction because the CH3 is electron donating, so the bromine will go to ortho and para, not meta. So if you want to make this one, you have to go from diazonium salt. Okay. You need to use this reaction, PUBR. Okay. So if you can go with the conventional way, then go with the conventional. You don't need diazonium. But if you cannot go with traditional method, then remember the diazonium. For example, here, conventionally, the bromine will go to ortho and para because the CH3 is electron donating, not meta. Okay, if you want meta, you cannot use conventional method. So remember the diazonium salt. Okay, you will see this reaction many times in your exam. Okay, let me continue the lecture. Okay. All right. Let me continue. We can use CuBr, CuCl. Okay. CuCN. Okay. You will see all of these reaction in your final exam, so you need to be very careful. Okay. CN here. Okay. Let me ask some of you. Phạm Công Toàn, are you there, Toàn? Phạm Công Toàn.
Yes.
Okay. Can you tell your friend? Look at this one. Benzene C-triple-N, meta-bromobenzonitrile. Okay. If you carry out the reaction between this one and hydrogen with nickel catalyst, what is the product, Toàn? What is the product, Toàn? Can you hear me, Toàn?
With CH.
C?
CH2NH2.
Okay, good. CH2NH2. And if we carry out the reaction between this one and water with acid catalyst, what is the product? With water, what is the product? What is the product one? What is the product one with water? What is the product one? Your friend told us half an hour ago. What is the product? See? What is the product one? You don't remember, Quang? And you didn't listen to your friend. Your friend told you half an hour ago. Okay, thank you. Okay, I say again, turn off your microphone. If you carry out the hydrolysis of C-N, I mean the reaction with water, you have COOH, I mean carboxylic acid, okay? If we carry out the hydrogenation reaction, we have CH2 and H2, that is amine, okay? If you want to add an iodine atom to the benzene ring, we cannot use copper, we need to use Ki, okay? And if you want to add a fluorine, we need to use HBF4, okay? HBF4, you can use sodium and ABF4 as well, okay? Second reaction, that is the hydrolysis, okay? We can hydrolyze diazonium salt, and then we have phenol, okay? Again, let me ask you, are the method to make phenol? Nguyễn Minh Hoàng Yến, are you there, Yến? Hoàng Yến, are you there? Nguyễn Minh Hoàng Yến, are you there? Hoàng Yến, are you there, Yến? No. La Trúc Quỳnh.
Yes, sir.
Can you tell your friend how can we make phenol? This is one method. We have two more methods to make phenol.
From the benzene.
Benzene? How? Benzene and carry out the reaction between benzene and
Cl.
Cl, then we have chlorobenzene. Is that right?
And then we use NaOH to reduce.
No. Were you absent on when you were studying chapter 10? I asked you to take note. Do not use that reaction because you know the benzene ring is negative. OH is negative, so two negative cannot react. So do not use that reaction. Do not use that reaction. Anyone remember? We have a very popular method in you study that reaction in chapter 10. Cao Ngô Hoàng Ngân. Tell your friend how to make phenol Ngân from benzene. Ngân.
Hello.
Okay. Tell your friend how to make phenol, Ngân. Tell your friend ask the method to make phenol. For benzene. To make phenol from benzene. Okay. In chapter 10. How? Ngân, how Ngân? I asked you to take note in chapter 10. How?
I think I missed it.
Were you absent in chapter 10?
No.
So the reaction to make phenol in chapter 10. Chapter 10 is about alcohol and phenol. Oh my God. Okay, thank you. You might have to see us again in next year, next semester. Okay, let me stop sharing it and open chapter 10 because that is important. Chapter 10, where is chapter 10? Chapter 10. Let me open. This is chapter 10, okay. So, we can make benzene sulfonic acid, okay, from benzene by the reaction between benzene and sulfuric acid, high temperature, and then heat it with solid sodium hydroxide or potassium hydroxide, okay. Then we have phenol, okay. A long time ago, people used chlorobenzene, but this reaction gave low yield, okay. So do not use this reaction in your exam. I mean, do not use the second reaction in your exam, okay? Another method, we can make phenol from cumene, that is isopropylbenzene. We carry out the oxidation reaction, and then we have phenol and acetone. We have two products, okay? This is how people make phenol in the industry, okay? Okay, so in chapter 10, I asked you to take note. You will see this reaction in your exam, okay? From diazonium salt by the hydrolysis reaction. Okay. Next reaction to remember is the reductive deamination reaction. I mean, we remove the amine group from benzene ring. Okay. First, we convert it to diazonium. Okay, and we use a reducing agent like NaBH4. Or H3PO2 or anhydrous C ethanol. I mean, anhydrous means zero water. If you have water in ethanol, then we have ether. Okay. So we remove the amine. Okay. So this is the way. This reaction is very useful when we want to block a position in the ring. Okay, and let the reaction occur at ortho or para position to the amine, and after that we remove the amine. Okay, and the final reaction. Okay, the final of the final chapter. The final reaction is azo-coupling reaction. Coupling means two become one. Okay, that is the reaction between phenol and benzene ring and diazonium. You know, this ring is negative, this nitrogen is positive, so we have something like electrophilic substitution reaction, and we have N double bond N. This is azolink. Okay, azolink. Azolink. Sorry, I need to hear the phone. Sorry. So this is a electrophilic substitution reaction. Okay. Okay, so let me ask you something. You will see this reaction in your exam. Hồ Minh Thư, are you there, Hồ Minh Thư? Hồ Minh Thư. Hồ Minh Thư, are you there? Hồ Minh Thư. Trung, Trần Nguyễn Vĩnh Trung, are you there? Trung. Absent. Nguyễn. Let me. Trần Tiến Huy. Huy, are you there? Huy, Trần Tiến Huy.
Yes.
Okay, can you tell your friend? Okay, look at this acyl coupling reaction. Okay, so if you want the reaction to occur easily, okay, you have electron donating group on which side and electron withdrawing group on which side. So we have two sides. Okay, the diazonium and the benzene ring. Okay, we have two starting materials. Okay, two reactants. Okay, so if you want the reaction to occur easily, okay, so you should have electron donating groups on which side and electron withdrawing group on which side.
I think electron donating group on phenol.
Okay, phenol. And
Electron withdrawing on diazonium.
Why is that? Why is that?
Because the ring of the phenol is more than negative.
Okay, good. More negative if we have more donating. Okay, and diazonium?
Diazonium is more positive.
Positive with electron withdrawing. Okay, very good. Thank you. Okay, thank you. Okay, I say again, everyone listen. You see this reaction in your exam. Okay, so in this reaction, you know this nitrogen, I mean the diazonium is positive, and on the other side is negative. Okay, so if you want the reaction to occur easily, you should make this nitrogen more positive. So you should have electron withdrawing group on the diazonium. Okay, and on the other side, you want the ring is more negative, so you should have electron donating. Okay, so you might see this reaction again in your exam. The final exam is the traditional exam, not the multiple choice exam. Okay, you need to write out everything. Okay, because offline, we will do the exam offline. Okay. All right. So that's everything for the chapter. Okay, this is some example. This is some example of the application of diazonium. Okay, if you want to make dibromo, okay, we have two dibromobenzene, a meta dibromobenzene like this one. Okay, if you carry out a direct bromination reaction to bromobenzene, the second bromine will go to alpha and para. Okay, so we cannot use the traditional bromination reaction. Then you use diazonium. We start from nitrobenzene. Of course, from benzene we make nitrobenzene. Okay, we carry out the bromination reaction. So the bromine will go to meta because the nitro is electron withdrawing. Okay, and then we introduce NO2 to NH2 and convert it to diazonium and use the Selmayr reaction with copper 1 bromide, and then we have meta dibromobenzene. Okay. Second. Let me ask you something. Look at this. Pay attention, everyone. Pay attention to slide 32. Pay attention to slide 32. Okay, look. You want to add nitro group to para position of aniline in aniline. Okay. So why don't we carry out the reaction between this one and nitric acid? Because NH2 is electron donating. So the second go to ortho and para. Why don't you do that? Why do you have to convert this one to NH amide and then carry out the nitration and then hydrolysis back to amine? Okay, so I give you 5 minutes to think about this. Okay, and then I will ask you. You will see this reaction definitely in your final exam. Don't we carry out the direct nitration reaction of aniline? So go from here to here directly. Why don't we do that? Okay. Why do we have to convert the NH2 into NHCO, CH3 before the nitration reaction? Okay, so I give you 5 minutes to think about this. Okay, so everyone, for example, if you have NH2 here, NH2. Okay, is this reaction correct? Everyone, can you see this reaction? Everyone, can you see this reaction?
Yes, teacher.
Okay, is it correct? Is it correct? Is this reaction correct? Is this reaction correct? Anyone know?
I think the main production will be NO2 at ortho position.
Also, why? We have ortho and para. Okay, so we have this one. Okay, let me give you both products. Click. Okay. Is it reaction correct?
I think no.
No. Why is that?
Because the NH2 group is the base group and
okay,
the HNO3 is the acid. So the reaction between the acid and base must happen first.
Okay, good. So what?
So it becomes the like NH2 and NO3.
And sorry, NH. NH2? NH3, good. NH3.
NO3.
Okay, and then if the nitro we go to, the second nitro we go to, you access nitric?
The para position.
Is it para?
Oh, meta.
Meta, okay,
meta,
thank you.
Meta.
Okay, thank you. Everyone, attention. Thank you, Wing. Okay, so everyone, you might need to take note. Okay, do not carry out the direct reaction like this. Okay, because in a acidic reaction, this NH2 will become what? We become NH3 plus. Okay, this is the base. Okay, so the NH3 NO3. Okay, so I mean NH3 plus. So this is electron withdrawing. Okay, this is not donating anymore. This one is not donating anymore. The NH2 is donating, but the NH3 plus positive is donating anymore. So if you carry out this reaction, sorry. Nitro, sorry. If you carry out the reaction, okay, it will go to the meta position. Okay, it go to the meta position like this one. Okay, and after hydrolysis with a base, we have NH3 plus become NH. Okay, so everyone take note, take this note. So do not carry out the direct nitration like this, because the nitro we go to meta position, not ortho, not para. Everyone take note, everyone take note. Everyone take note. This is important. This is very important. Take note. I say again, do not carry out the direct nitration of aniline. Okay, take note. Okay, because NH2 is the base, it become a NH3 plus, and it's become electron withdrawing, not donating anymore. So the nitro will go to meta, not para. Okay. Take note, everyone. Take note. This is very important. All right. Let me go back to the go back to the example. Okay. Look. So instead of carry out the direct nitration, people need to convert NH2 to the amide by using anhydride or CH3COCl. Okay, both are okay. Okay, and then we have NH2COCH3. This is amide. This is not a base, strong base anymore. Okay, then people carry out the nitration reaction. Okay, it goes to ortho and para. Okay, we can take normally the main product is para. Okay, and then carry out the nitration. Okay, we have para, so we have this one, and after that we hydrolyze the amide back to amine by using acid or base at high temperature. Okay, so remember, never carry out the direct nitration reaction, because the NH2 is the base. It is converted to NH3 plus first, and it's become electron withdrawing, not donating anymore. Okay, so the second go to meta. Okay, same thing here. Okay, look at this one. NH2 is donating. Okay. If we carry out the direct nitration, nitro will go to meta position. It writes to ortho of the isopropyl group and meta to the NH2. Not here. Okay. So we need to convert NH2 to this one, and then nitration. Oh, this is electron donating. This is electron donating. Okay. And this is more donating. We got donating by C conjugation. So nitro will go to here. And after that, we hydrolyze the amide back to amide. Okay. So again, do not carry out the direct nitration reaction of aniline, NH2. Okay. Because NH2 becomes NH3 plus, and it becomes electron withdrawing, not donating anymore. Okay. More example, we have NH2 here. We use anhydride and become NHCOCH3. Okay, and we carry out the chlorination reaction. Okay, and we go to here. Okay, because we need a Lewis acid here, ion here, FeCH3 here, Lewis acid, and will react with NH2. Okay, so we need to convert to the amide. Okay. Remember that note. Okay, now I give you things to do. Your final exams, you have some questions related to diazonium salts. Okay, you need to in the final exam, you need to repair two compounds. One compound, we use the knowledge up to carboxylic acid. And the second compound, we use the knowledge from the chapter diazonium, okay? And in the final exam, we have two long reaction sequences, okay? Two long reaction sequences. One is up to carboxylic acid, and the second one is from the chapter diazonium salt, okay? So now I give you examples to do, okay? Okay, first exam, okay, complete the exam and upload your answer onto BK e-learning.
Yes, teacher.
Okay, good. You two correct it. Okay. Everyone, take the picture. Take the picture of the question. Take the picture of the question. Okay. Take the picture of the question. Let me open the file. Let me open the file. Where is it? Where is my file? Okay, here it is. Here it is. Check the first section. Let me share the screen. Can you see the question, everyone? Can you see the question? Can you see the question, everyone?
Yes.
Yes.
Okay. Take the picture. Take the picture of this one. Take the picture. Okay. Take the picture of this one. And I give you one more. Take the picture, okay? Take the picture. Okay, so from starting material and then you have C, A, C, okay? Okay, done. And then take the picture of the same with D, okay? The same question but with B and D. Okay, take the picture, the same question with B and D. The same question with B and D, okay? Can you see B and D? Okay. Okay, take the picture. Okay, take the picture.